Stuart.
Hey, Jill.
Here we go. We've been waiting for some time now. This has been in the works for a while. And actually, I would say 10 years that I have, 10 years have led me to this point of having Dr. Nicole Deziel. She is the Associate Professor of Epidemiology at the Yale School of Public Health and co-director for the Yale Center for Perinatal, Pediatric, and Environmental Epidemiology. So, Nicole, good afternoon. How are you today?
I'm doing great, Jill. Thanks so much for having me. And yeah, it's hard to believe that we really have been connected for about 10 years. It's really quite extraordinary.
And I have chills because that's a long time. You know, like we've both been at this for quite some time. And what's interesting is that, of course, would love to hear, you know, your background and how you will present yourself here. But yeah, I think in 2015, we were both kind of beginning, you know, in our careers and supported each other. And so I'm just going to stop there and just, you know, love to hear how you would introduce yourself here to folks.
Yeah, so I am an exposure scientist by training, an environmental epidemiologist. So my work is focused on trying to understand who and how people are coming into contact with the many different legacy and emerging environmental contaminants. And one of the main areas or pollutants that I study are those generated from unconventional oil and gas development, also known as fracking. Part of my time is doing research on those exposure topics. I'm also teaching and training graduate students in exposure science and environmental epidemiology. And doing other types of service projects, and research, translating research to the public. So, and this is one of those types of examples of kind of translating research to the broader audience.
Can you go back and tell us how you got into this field in the first place? What drew you to studying environmental science and exposure science specifically?
Yeah, so I grew up on Long Island in the 1980s, 90s. And at that time, there were a lot of suspected cancer clusters. Breast cancer rates seemed to be unusually high. And my neighbors, my community, people were, wondering what could the cause be. People thought it was maybe above ground power lines or on the eastern part of Long Island, where I grew up, there were also a lot of pesticides. There was this research laboratory that worked with radiation. So there were all these theories and speculations, and nothing ever really got well established. But that kind of made me think about, what are all the ways the environment impacts health. And then another thing I really haven't shared publicly, but I myself had a health issue. I actually had a brain tumor when I was a senior in high school. And wow. It was very rare. It turned out to be very benign. But one of the things the doctor said was, we don't know what caused this. It could be related to the environment. And when I just started doing a little bit of looking into it, I just realized there were just so many gaps and uncertainties about how the environment impacts people's health. So then I went on to University of North Carolina, Chapel Hill, and luckily they have a great program in environmental science and engineering and public health. So that's kind of where my path started.
And so when you started, was it was more just kind of general environmental science and exposure, or did you sort of start in one place and work your way to specializing in what you do now?
And it wasn't the first study that we worked on together here in the Ohio River Valley. Wasn't that your first research project? Or am I remembering that correctly?
Yeah. Well, I guess it was the first field study that I directed myself. But yeah, to go back to Stuart's question, I guess another thing I learned in my training at UNC, and then I went on to Johns Hopkins to get my master's, then doctorate in public health, environmental health. One thing we heard over and over again was that in these environmental epidemiology studies that look at environmental health risk factors and disease, the weakest link was always the exposure assessment. So how to figure out, what exactly people were exposed to. Like in the example I mentioned with Long Island, well, how do you assess exposure to pesticides? Do you give people a questionnaire? Do you take some measurements? You're going to collect their blood. You're going to measure their soil, their water, all of these things. So it was constantly, we were constantly learning that, to do that is really hard, and to do it well, to do it accurately and precisely is really challenging. And that was kind of always touted as the weak link. And kind of any study I read in my graduate training, like in the discussion where they go over the limitations, there would always be something about, we could have error in how we assigned exposures. So that kind of motivated me, because I was like, well, this seems to be the weakest link of this field. So I'm going to try to learn more about how to do that better.
Yeah. And so how did you end up with this first field study that you directed where you met Jill?
So by then I was a new assistant professor at Yale. I had led a number of studies and collaborated on a number of studies up until then, but hadn't ever kind of gone to the field and directed my own study where I was managing kind of everything from, conceiving of the idea and trying to figure out the protocols and of course, everything we do in science is a team effort. So I always have a lot of collaborators. But yeah, so I got interested in, I guess, fracking in particular very early on, even before I got to Yale, when I was a postdoctoral fellow at National Cancer Institute. It was just coming up in the news a lot, this new industry, fracking, and a couple things got my attention. One was just the sheer pace of the expansion of this industry. And I was reading other scientists, raising concerns that public health considerations weren't adequately being addressed, and this industry was kind of moving forward. And there really didn't need to be a rush, because these fossil fuels, have been formed in the ground for millions of years. They weren't going anywhere. So why not stop and kind of understand the public health implications before just charging forward with this industry? But it did seem to proceed rather quickly without all of those studies and information being done up front. And again, I just thought, okay, this is something too, like a lot of the chemicals that could be emitted from this industry were things I had been learning about throughout all my training and studying as part of my research as a PhD student, a postdoc, like polycyclic aromatic hydrocarbons or PAHs, benzene, diesel exhaust, all these things that had the potential to be emitted from oil and gas sites were, well-established carcinogens that I had been studying myself and learning about it. So I just thought I really had some expertise to be able to bring to this work.
And then, if we're very specific, I would just want to honor Joan and a dear friend that I actually hadn't seen for years and did not know that she was at Yale at that point. But it's through Joan that reconnecting with her that she introduced me to Nicole. And then that was kind of, wouldn't you say, I mean, you were here, that was, I'd say the height, of the boom, really. It was early on, and things were really in high production when you were here that first time.
Yeah, and I love this story, actually, with Dr. Joan Monin, who's a colleague of mine at Yale, who doesn't do anything environmental. She's a fantastic researcher who studies aging and dementia and caregiving and and well-being throughout the aging process. But we just were friends, colleagues, and I happened to be talking about fracking, how I really wanted to study this, but recognizing I was kind of an outsider wanting to come to inside a community to do this work. I'm from New York. Like I said, I was a professor in Connecticut. We don't have any shale in Connecticut, at least. New York actually had a moratorium at the time, so there wasn't a lot to study there. So the closest place, closest to me was the Marcellus Shale in Pennsylvania and Ohio. And, just happened to be talking to a colleague and a friend, and she said, "Oh, I have a friend who's a community organizer, in Ohio." And it was great. It was just the perfect entree I needed to, get to know a little bit of the lay of the land and, talk to someone whose actual lived experience was, in that area with all of that boom. Because that is so important for research. I think, I don't know what people kind of picture when they think of a scientific researcher, but at least for public health, it's not, a scientist alone in a laboratory with beakers. Public health, we have to go out in the community, work with people. Environmental health, we have to collect samples. But to do that, you really, need to engage with the community who's actually experiencing the industry, to be able to do it well and try to build trust so that people will be willing to open their doors and let you come in and test their water and things like that.
And so can you walk us through what it was like? So you had this academic scientific interest in fracking. Here you had this opportunity to actually conduct your own field work. What was it like walking into that world and learning the things that you learned? I mean, how eye-opening was it for you?
Yeah, so I went down, it was January 2016 when I first went down kind of on this reconnaissance mission, I would call it, to meet with Jill. And Jill was gracious enough to take me. And I also want to give credit to my doctoral student, Elise Elliott, at the time. She was another huge motivator where I had this interest, as you said, Stuart, and Elise needed a project and she needed to graduate, and she had a lot of courage and bravery to just, we should just go do this study. I'd been thinking about it for a long time. So sometimes students are the best motivators to get you moving on a project. But yeah, Elise and I went, and Jill gave us some tours. And I mean, yeah, you can read about it all you want, but I found it really striking just seeing, the scale of these well pads, the noise, the impact to the ecological landscape. Yeah, it was pretty eye-opening. And then talking to people in the community, local school graciously hosted us and, just talked to people about what they were concerned about. So that was really key to helping me then take that and form it into some hypotheses for the research.
And what was that? Will you remind me, what were you here to discern, determine, or yeah?
Yeah, we did a pilot study, which again, it's so important for research. Before you're going to launch this big scale effort, you want to test out your protocols and see, is this feasible? And get some preliminary data to see if you need to make any adjustments. So that's really an important part of research. So we did kind of a smaller scale study. We collected air samples, water samples. We did an interview. We asked people about their symptoms. And that study just provided the basis or the foundation for an even larger study that I came back and did later.
And basically, if I remember, it was determining if there was an association between certain water contaminants and air contaminants and the proximity to oil and gas infrastructure or well pads, or was it specific? Am I right in remembering that?
Yeah, that's right. Thank you. That was an important piece of the exposure. Yeah, we tried to go to homes that were both close to and far from unconventional oil, gas, or fracking well pads. And I guess we were also interested in the injection wells at the time, which are the waste disposal wells. Yeah, I get our hypothesis was, or our question was, do people who live closer to oil and gas well pads have a greater number or level of contaminants in their water or air, or do they have a greater likelihood of some health symptoms, things like that?
And at this time, was this like, how much research was going on in your field at this time with fracking? Was this sort of one of the first studies, or how does it land in that landscape?
Yeah, there was very little done for unconventional oil and gas. I mean, there had been some studies of more conventional drilling, but this whole industry was so new. It really only took off, for example, in Ohio around 2010, 2011, right, Jill? So this was just a few, and research takes time to do and then publish. So at this time, around 2015, 2016, there was very little that had been done in the way of health or exposure studies specifically. So this certainly wasn't the first, but it was among the first. And also there had been very little done in Ohio. A lot of researchers were focused on Pennsylvania.
Yeah. Yep.
So there wasn't a lot going on in Ohio. Is that what you remember, Jill? Can I ask you questions?
Yeah, please go ahead. Yeah, no, that's how I remember it. And to be honest, I still feel like in general, Pennsylvania gets more research, more coverage, more interest, more help than Ohio and West Virginia, for sure. And so then back to that first study, I was pleased with the amount of participants that were joined and willingly participated. But for me at that time, you were the backup that I need. You were what we needed at that point, because I'd been active. I'd been trying to spread awareness. I knew there was some other research. I knew our lived experiences. I knew the impacts from local community members and even industry workers at that point. But it also helped me establish this community science in my work and how crucial it has been throughout. And so I just want to take a moment now and I'm going to try not to cry already, but how grateful that I was then and continue to be for you and what you the service you provided to our community. Also a sense of hope, we aren't forgotten. Someone actually cares. They're actually trying to help us. And then, with that first study, I feel like the feedback we received was that it confirmed, the results kind of confirmed that further studies needed to take place and were warranted.
Yeah. And I mean, I can't underscore how much having, Jill, having your kind of connections and, allowing me some credibility with the community, again, being from, an sort of an outsider, I guess. I just can't underscore how helpful that was just for me to get the research off the ground, and to get you helped get the word out and, just to really help make the study possible. So I appreciate so much, your role in that. Because it was a smaller study, we found some contaminants in the water that were a little unusual. We did find benzene, which is a known carcinogen. And then even in some well water, we found these disinfection byproducts, which normally you see that in public water that's been chlorinated. But it was all very, it wasn't very conclusive because we had a small number of homes. But luckily having that study helped me get the next study, because that's kind of research is kind of incremental building blocks, building on top of each other. And in around 2016, 2017, the EPA had a special grant for fracking research and health under the first Trump administration, I would add. And they only awarded one $2 million grant in the whole country. And my team got it, me working with my colleague, James Sayers, who's a hydrogeologist, and Desiree Plata's a chemical engineer. So, and many others. It was a big team. But yeah, so having that pilot study really helped me show that I had the ability to carry out this much larger study.
That's so fantastic. And so I guess there's so many places we could go from here, but can you just briefly make the statement of, so that was like 2016. And so in the last 9 years, you've been busy, dear. And pretty amazing, impactful research. And so, yeah, I mean, just a general summary of like, so you've been very busy and like 30 studies. Where are you now in as far as, you've continued on this path, obviously, since that first $2 million grant. So
thank you. I think we do have, I think there's at least 30 publications from my research group. Again, with big team effort, a lot of students and postdocs leading some of those analyses. Yeah, so we've tried to look at not just this question of drinking water impacts, but health impacts. So we've studied cancer outcomes, birth defects. We've looked at those waste disposal wells and where are they sited, because there's a little more flexibility about where you put a waste disposal well versus, you have to drill an oil and gas well over the shale, but the waste can go more places. And, so looking into environmental justice implications of where waste disposal wells are. So, myself and others in this space have contributed, again, thinking about the field now, not just my research, but at least 50 epidemiologic studies documenting, adverse health impacts to people, communities living near oil and gas sites, as well as, dozens of other monitoring studies, as well as environmental justice studies. So there's, in that time period, really only 10 years, actually, I think the research community, that was kind of caught behind because this research, the industry sort of took off very quickly. And us as the scientists we're often like trailing behind trying to understand the impacts. So in 10 years, though, I would say the field has come quite a long way to, produce a voluminous body of work kind of showing some of the health impacts.
When you did that first study, were you thinking at that time that this is going to turn into such a big chapter of your life? Or was there a moment when you realized like this is a big thing that needs to be continually, that you have to follow it down this rabbit hole?
When I first did this study, I really thought, okay, this industry, it just seems huge. It's, taking off. It doesn't seem like it's slowing down. There's all these potential health issues. There's potential for air emissions, water. There was like the earthquakes. There were just all of these things. So I really did think that it was pretty big. I was hoping that this would be something I could focus my career on. Again, a lot of my training had really well prepared me to study this. So I guess I was hoping that I could, because I thought there were a lot of gaps in the knowledge. And I'm just fortunate that I, made the connections like with Jill and had my great collaborators at Yale and, got the funding to be able to do all that work. Yeah. And also, I will say, though, Stuart, at the time, it was a little controversial, not that many people were working on it. And it was kind of seen as, it many ways it still is politically like controversial. And I was a brand new assistant professor, and some people just thought I should maybe play it a little safer, like not wade into this, new industry with a lot of political ramifications. But, I just felt like this was really important. So I kind of trusted my instincts. And again, I had at least my brave doctoral student who was also really passionate about this. So anyway, I'm glad I did. And I also, try to diversify research. So I had a few things that were a little more, maybe more like stable, and to kind of balance this out if it didn't work out. But I'm really glad it did.
Was it? I'm just curious, that controversy, was that coming from like inside academia, or was it coming from other places? Where were you feeling that sort of pushback from?
Yeah, a little bit from, like some well-intentioned, I think, more senior mentors just urging, having some caution about not sticking my neck out, like establishing my credibility first before taking on such a large industry. But I kind of think that's just doing environmental research. And first of all, I was there, as Jill knows, I was there just to collect data.
Yeah.
I didn't have an agenda.
Nope.
I didn't know what we would find. So I just felt like if I just do the best science possible, why wouldn't I do something that's policy relevant? What's the point if it's not going to be relevant, or people aren't going to care about it? So
the way you approached it, was so brilliant because you weren't anti-oil and gas. You were very clear that you were here, just like you said, to collect data, and you didn't know what you were going to find. So I think that helped, like that you could come in here, and I guess that's how all researchers should be anyway. But anyway, I just was very happy how well you were received, and folks that had benefited from, financially and supported fracking, were willing to participate, and I wasn't sure at first if that would be the case. So that was really good. And then, Can
I add a story there? Because I think, some people in the study even were, very supportive of the industry, were benefiting, financially. So there were a lot of different opinions about it. And I tried to be really clear, like we just didn't know what we were going to find. I mean, some people may have wanted some data to support their position, whatever it was. But the one thing that people in the study seemed to want, they just wanted information.
Yeah.
Because there wasn't, a lot of people were served by private wells, not the public water, and many people never even had their water tested. So, first and foremost, I think the purpose was to get information and also provide that information back to the community, regardless of what it was, and to manage expectations that, people may have some preconceived ideas of what they wanted the data to say, but, the data are what they are.
Maybe not long after you were here the first time, like we started hearing that there was going to be an increase in fracking. It was going to pick up even more because I learned about the PTTG ethane cracker plant that was proposed to be built here in Belmont County. And so suddenly, even though I didn't know this before, but, plastic comes from fracking? I had no idea, and so then not only was it the increase in potential, like 1,000 additional fracking wells to support one of these cracker plants, and originally they had 6 planned for the Ohio River Valley. Only one of them was built. So then I guess I'm wondering, like, if there was a point too when you became aware of that, and if you have done any work in, the connection between cracking for plastic and fracking, or the petrochemical industry in fracking, if you at any point were led to that aspect of this industry?
We certainly heard about the cracker plant from the participants. Many people asked us about that. And this is another benefit of being on the ground and talking to people, because again, their lived experience can inform, what are the questions that are most important to them? What are they worried about? And then you can adjust your scientific research to kind of match what the community is interested in, or what policymakers might need to sort of support their efforts. So we certainly heard about that. And I also had concerns, again, with this rapid expansion of this industry, building these new pipelines and the wells and the infrastructure, and then having this downstream kind of plastic industry. It just seemed to increase the longevity of the industry. Even if we do move towards decarbonizing our electricity generation, now there's a whole new path and revenue stream for the oil and gas.
So I would love if you could just share a little more information about your study on the petrochemicals. And I think it was related to kind of an EJ issue, environmental justice issue, and also, I'll just stop there. But I'd love to hear a little more about that if you could share.
Yeah, after hearing from our participants that they were really concerned about new cracker plants being constructed, we did a study to look into, kind of what are they, what types of pollutants are they emitting, and where are they located? Cracker plants take the petrochemical hydrocarbons and convert them into feedstock that's necessary for making plastic chemicals. And through this cracker process, they emit a variety of pollutants. So in this study, we used all publicly available data looking at the types of chemicals that are emitted. And they do emit some known carcinogens like benzene and 1,3-butadiene. And we also found that they were more likely to be located in areas that already had higher proportions of people of color.
And so was that study done in Louisiana by any chance, or where were you looking at those issues?
We actually looked at all cracker plants in the country. So many were in Louisiana, Texas. We just looked at nationwide, where are they located, what states, and what were the kind of demographics of the communities compared to communities that were nearby but not hosting these types of facilities.
And you said it was publicly available data that you were pulling from. Is that like self-reported data from the industry?
Yeah, so this is EPA data from the Toxic Releases Inventory, where it's kind of came out of community right to know legislation from the EPA, and industries emitting certain chemicals on this list of hazardous pollutants have to report, how much they're emitting from their smokestacks or, their pipes or whatever, to air, to water, to land. And it is self-reported, Stuart, as you mentioned. So that does raise some concerns. There are also estimates kind of from algorithms. So that is just one caveat with the data. They're kind of estimated industry reported numbers.
That seemed like you were saying earlier that, earlier in your career, you kind of identified the blind spot of environmental health studies was exposures. And it seems like from all of the things that I've kind of read and experienced doing the work that I've done with Jill, it seems like that is one of the big blind spots as well, is that a lot of the information we have is self-reported information from the industry. And I think that there's been cases where that self-reported data has been found to be underreported or inaccurate. Have you, experienced that in your work?
It is an important concern. Others have looked into kind of checking these types of emissions. I haven't really looked into it myself because what's the gold standard then? We'd have to take measurements at the smokestacks and kind of compare them. But there have been studies looking at sort of ground truthing some of these estimates. And I would add also though that emissions doesn't equal exposures too. So once the chemicals leave the smokestack or the facility, they do get diluted or transported. People nearby may or may not be exposed to harmful levels, just because it's being released. There's a lot more to try to connect. That exposure is about taking those emissions and connecting them to the people, to the human receptors. And say you live near such a facility, but you may not work there, you may not go to school there, you may go live somewhere else. So there's all these other factors that also contribute. But getting back to your question, yes, I think it can be challenging dealing with self-reported data, whether it's, voluntary, the frac focus, for example, industry volunteers to provide information about their fracturing fluids and things like that. But we kind of have to do the best we can with the data we have available.
I mean, is that something that you wish you could see more? Like, if you could wave a magic wand, knowing everything that you know, would you like to see more third-party, independent reporting and monitoring of these things?
But isn't third party the problem? Is it government or research? I mean, it is a third party that goes in that the company hires, the industry hires. So explain that to me. I'm a little confused right now. Like, ideally, we would have a non-biased governmental agency come in and do this assessment and not have the company pay for someone to. Okay, I'm stopping.
Yeah, no, I think, Stuart, you raise a really good point. Absolutely. We need more exposure data. So the EPA has air monitors located throughout the country. However, they only monitor for a select list of chemicals, and they also tend to be located in more densely populated urbanized areas because that's where there's more people. So again, rural areas, we just have less information about air pollutants. Drinking water is another one where drinking water utilities, public water systems, they do test their finished water, but contaminants can be introduced, like lead, between the distribution system and the tap. And then if you're served by a private well, again, in rural areas, the only person who has the authority to test your water is you. And you would have to, pay, or you may be able to get some government services to get some water testing. So, and then we have, for example, the CDC does some studies. They take blood and urine samples from like a representative sample of the population. They measure for a few hundred different environmental pollutants that we kind of have floating around in our bodies. But again, all of these are just a tiny fraction of the chemicals that are in our products, our air, our water. So I absolutely agree. This would be a lot easier if we had a lot more exposure data. But we are kind of limited to a small fraction of the known agents that we test for.
But earlier you mentioned exposure assessment. So can you explain to me what that means? And you saw that was an area that needed refinement, improvement. And what does that look like for you?
Yeah, well, hopefully this doesn't sound too much like a teacher, but I teach a whole class on this. But I mean, really, exposure assessment is trying to understand how individuals come into contact with their environment and what's kind of the nature of that exposure, like how frequent, how much. So, for example, if we were concerned that people who live near oil and gas wells might be at higher risk for cancer, we'd want to know, well, could there be something in their water? Could there be something in their air? so we would try to assess their exposures. So we have 4 types of tools that we use as exposure scientists. We can do surveys where we ask people about things they can observe, if they smell something, if their water, tastes different, if they hear noise is something they could certainly report. But it's hard because a lot of these pollutants are invisible, colorless, odorless, so surveys are somewhat limited. But you can also ask people about kind of where they're spending their time, how much they're outdoors, how much they're indoors, if they have a water filter, things like that. Then we can actually take environmental measurements. We can test the water, the air at their home. Can have people wear a sampler, like there's these wristbands now that kind of collect pollutants and they go with you into all your different microenvironments. We can do biological measurements, so collect blood or water and test for chemicals. And then we can also model things. So we could model like emissions, as we talked about, or model drinking water pathways, model proximity to oil and gas wells. So those are the types of things we can do to try to assess exposures. And I'll say they all have strengths and limitations. And if you can do a couple of them, sometimes, more than one, they can provide complementary information. Because maybe it's important to understand what people are perceiving. If they do smell something or they're hearing noises at night, they can't sleep, so having some of that contextual information can complement, the measurements. I could keep going on this too, because, with measurements, it's hard to know, what do you test for? There's a lot of different potential hazards out there.
So now 30 peer-reviewed studies or papers you've written. I would love to know, in your research, is benzene always on the list? Like, are there certain exposures to certain chemicals that continue to come up in present? Am I making sense, Stuart, what I'm trying to ask here?
Yeah, kind of. What's the treetop version of what you've gleaned? Like, we should say to listeners, this is going to be a 2-part.
Or 3 or 4
3-part
or forever, ongoing, as many times as she'll come talk to us.
Yeah, and we are going to dive into more of the details on Nicole's research. For this episode, we're trying to keep it a little bit more background, but it would be nice to know kind of generally what have you gleaned from all of this work you've done when it comes to unconventional oil and gas.
Yeah, so I'll talk about my research. There's also, of course, my research is one small piece of this broader field with other researchers generating their results and good studies. But in about the 30 studies that I've done, I've tried to look at the impacts of oil and gas from multiple lenses. So looking at the health piece, several of our studies have found greater likelihood of health problems, greater rates of health problems in children who live closer to oil and gas sites compared to those who live farther away. We've also, second lens would be environmental justice. We've found some environmental justice issues that some of the oil and gas infrastructure is disproportionately located in areas of lower income, for example. And then the third lens is the exposure piece, where I've particularly focused on drinking water. And that one's a little more mixed. I would say that there hasn't been a clear link. I could get into the details, but that one is a little more complex. But living near a site did not translate to automatically having higher contamination in the drinking water by any means.
I'm just thinking about that one for a minute because then there's also like the pathways to contamination to the water. I mean, how many are there? Is it just like, oh, there's a blowout on the pad or an accident or a leak, and so it migrates down into my creek, down in the hollow? You were there. You know where I used to live. Like, or is it, that's the other thing, like how the pathways to contamination as well, like especially with water. Like, so do you look at that too, or?
Yeah, so that's why I work with a hydrogeologist, other collaborators who are experts in that. But you're right. You're really putting your finger on a complicating factor with water. Proximity isn't the best predictor of water contamination especially from oil and gas, for several reasons. And as I said, my study and many studies have not found like these broad patterns of contamination just by living close to oil and gas wells. The studies have not found that. And I think that is likely because, as you just said, Jill, for something to impact the water, generally something has to be off normal, like not working according to the best protocol, like a spill or a leak or a blowout. Something like that has to happen really for the water to be contaminated. But then there's so many other factors: the direction of the water flow, the solubility of the chemical, the affinity for the soil. So there's just the topography, so many other factors that kind of determine whether that, a leak or an emission actually translates, to contamination or exposure. So just as another illustration, I guess you could live very close to an oil and gas well. You could have one on your property, but if kind of the water is flowing away from your house, it's unlikely, even if it were to leak, that it would impact your well, for example. So that's just an example how proximity doesn't necessarily translate to exposure.
That makes perfect sense. Yeah.
So does that mean that, and I don't want to oversimplify anything, but does that mean that air pollution and like the emissions that are in our air is more of a concern? Is that what you found?
I don't want to say, I say no. That's my answer. But
I think that, there's a couple different distinctions that when you have diesel powered equipment and like hydrocarbons, it's not necessarily a continuous emission, but there is an emission to air as part of the normal operating procedures,
right,
for example, versus what we just talked about with the more off normal situation with water. I guess to not to be too cagey about it, but it's hard to say because the science hasn't really kind of yet shown like which is the dominant hazard. So I think with water, it could be, it is likely more episodic. Like we know that some water sources have been impacted. It's just not widespread. It's a little more episodic. Specific contamination events. The air is it's a different type of scenario where there can be kind of more continual emissions. And whether or not, but then I guess also air, it does depend on the directionality, the way the wind's blowing. There have been some studies looking at these types of factors. So I guess I could summarize, I would say it's complicated. It's not just one thing though, it may be a combination of different hazards, but I guess, it's a little hard to say, but some people might, for the reasons I described, may think air may be more of a priority to look at.
But can I just add in, because here's where my mind goes. How many people's spring well water is contaminated by whatever process, whether it was a leak or a spill or, from an injection well? Like, I also feel like there could be widespread water contamination, but who's testing it? I mean, how widespread the industry is and how many places spills, leaks would go unreported, undetected, because, they're the ones who report if there's an accident. So I also want to just state that. And this other fact, which is, and I think this has increased, and certainly as they continue to refrack certain wells, the amount of resources it takes to get out the gas is more intensive. So at one point it was 11 million gallons of fresh water to frack one well. So in my mind, the risk to water from fracking is the greatest risk because they have to use so much of it to drill or to frack the well, right? But that's not based on any research. That's just based on numbers and statistics. And once again, how much water it actually takes. So I just felt like I had to add that there.
Well, this does kind of lead me to a question that I had for you, which was like, what are the challenges of environmental science and doing this kind of work? Because it seems like it would be very, in a world that is so toxified, it seems, it would be very difficult to pinpoint, what toxin is
from what facility,
et cetera. But also what Jill just brought up, it's kind of like there's like how you classify things kind of matters, because there is widespread contamination of water. The water that they use for fracking becomes contaminated. But then you're also kind of have to look at, is it contaminating groundwater when it's not being used for fracking? And so it's sort of like how you classify and how you categorize the water or the air or the soil sort of makes a difference as well. And so what are the challenges that you come up with in your work, or that you confront in your work?
Yeah, these are such great points. So I guess one point to follow up on what Jill said is, we went to hundreds of homes in Pennsylvania, Ohio, and West Virginia, but we only went to each home once at one point in time.
Right.
So again, that's a challenge. That was an enormous effort to do that. But could have been a plume coming through, a month before, but we missed it, for example. Again, this goes back to the fact that people in rural areas who are served by private wells, we know very little about their water quality. It is not monitored. It's up to the homeowner to test. And then I guess, it's great. You're both raising a great point that each well generates millions of liters of wastewater. I've been really focused on drinking water, again, because that's where the person meets their environment, is with their drinking water. But this issue of the wastewater and where that goes, is certainly an issue. And, that's why we looked at kind of where the disposal wells were. But we know very little. I'd say there's been very little published about the fate of the wastewater. In some states, they treat some oil and gas, conventional oil and gas wastewater, and then it gets like applied in irrigation, as beneficial reuse of water after some treatment. So, there are a lot of things to think about with respect to the fate of wastewater from fossil fuel industry. And then Stuart, you raise another really great point, that we are all kind of exposed to many different things in our day-to-day lives. That's kind of modern society. And it is hard to disentangle the different exposures. And, if we do see that people who live near oil and gas wells have higher risk of childhood cancers, how do we know, that it's the oil and gas? Maybe it's something else. So, that's kind of the whole field of epidemiology, is trying to isolate those exposures, but it can be challenging for sure.
So how do you approach those challenges? I mean, how do you kind of attempt to parse out the different contaminants or the different possibilities? How do you link, at the end of the day, you study these health impacts, you study all of these contaminants. What is it that helps you actually link them together?
Yeah, so overall, as scientists, I think I try to tackle the problem with many different lines of evidence. And when doing a health study, we do try to control for other confounders. We call them other things that might be explaining this association. Could it be related to pesticides instead, or, something like that. So in our work, we did try to control for some other possible sources that could be related, higher in people exposed to oil and gas and higher in people with cancer, for example. So we try to control to the extent possible for other explanatory factors. And then also kind of it's really kind of doing all different types of studies. So we might do the health study, and we have done the health study on like thousands and thousands of people where we use kind of birth certificates. But then we can't go measure thousands and thousands of homes of water. So we do a smaller sub-study or a more detailed community-based study where we do more detailed measurements. And it really is kind of like a puzzle trying to piece it all together. I guess that's the best way I can explain it, to try to bring all these different threads of evidence together.
And so I think my next thought was, so you do all these studies, you put all the effort in, and then you submit it to, have it be peer reviewed. And so what does that mean? What that process and what does that give you? Like, we've had other scientists look at what we've produced, what our findings are, and then confirm that they agree, or just what does that mean for folks too, the peer reviewed process?
All studies that are published undergo this pretty rigorous peer review process where we submit it to a journal, and then 2 or 3 or even 4 other scientists that have not worked on the study at all but are knowledgeable about the field read it and critique it, and they check, are the methods appropriate? Did they control for other factors? Did they interpret their data correctly? Do these numbers look right? So all of these things. And then sometimes, they may have pages and pages of comments, not because you did anything wrong, but just suggestions or, things that they think need to be explained better. Then we as authors take it back, we revise it, send it back. We may go through this multiple times until these other kind of objective, scientists agree that it meets kind of the standards of the field. So it's not a perfect process, and it does kind of sometimes slow things down. Again, sometimes communities want answers quickly, and I can certainly appreciate that. But this is kind of our process, and it helps maintain the rigor and integrity of the work that we're doing.
I'm curious, what is your personal drive to do this work? I think it sounds like a lot of hard work. And it's got to be just, I'm sure that you have a passion for science, but you actually go, like you said, you're not stuck in a lab. You actually go and you talk to communities, and a lot of your work deals with topics that aren't necessarily they're heavy. It's a heavy subject matter when you're talking about kids and cancer and things like that.
Yeah, and that's what I'm wondering too. Like, how do you do that? So you go through this whole process. You do the study. You have the peer review process in order, and then you have these results to these families that potentially show an association between fracking and the childhood cancers. I'm just curious, and that's a heavy subject, but I'd like, if you can comment on that, I just would like you to.
I think just environmental exposures, many of them are involuntary. It's just by where you live. And I just think it's a false question that we need progress and technology, we need to sacrifice people's health to also have, progress and technology. So I just think it's people deserve to know the products they buy, if they're safe, that the industry near their home is going to produce energy, affordable energy, but not at the expense of the communities. So I guess that's really the motivator, that our field is designed to try to understand these things, because otherwise I don't know who would. I don't know if that's a great answer.
No, that is a great answer, actually. I think that's the perfect answer, because you're absolutely right. And that's what I've been trying to do since it showed up. The landmen started knocking on my door, is first try to understand what I could, educate myself about the potential risks and harms, and then, to try to educate others But where am I going with this? It's not what I want to be telling everybody. I wish I could be saying something else. I mean, I'm glad to do it. It needed to be done, but can't we just find a better?
It would help. I guess when I teach my class, sometimes too, my students find this a little depressing.
Yeah.
But I hope that it's not depressing. I would like it to be empowering. I think information can be empowering. A lot of these issues need policy solutions, really, or they should have policy solutions. But we can also make some choices with information, to help reduce our exposures. Yeah, so I know I don't like to be a Debbie Downer, but I think that's, you don't have to throw up your hands and say, oh my God, everything's so toxic. Some things are more toxic or less toxic than others. But I do think you're reminding me too that it's important to highlight solutions and what people can do, and not just say, here are the risks. And in fact, in my research, when we report the water test results and things, we always have some information about that's actionable, because some things are within our control. I mentioned some environmental exposures, many are not. They're involuntary because we can't control what's necessarily in our outdoor air or our water. But we can make some choices with information, or try to push for policy changes where possible.
And policy and our current situation in administration, and so it can get kind of heavy there too. But regardless, say they cut the regulations are cut and they're threatening that, there's still things we can do. Knowledge is power, and so what can we do to protect ourselves if we have to, and going on the solutions, we found out Barnesville Water, one of 21 in Ohio that has high levels of PFAS chemicals, right? So I'm like, great, just add it to the list of, the compressor stations and everything else that's going on. And, my skin's itchy, my hair's been really dry, so I found, and right now it doesn't matter, I'm not going to remember the name of the filter, but the top filter for my shower head that supposedly, I can't confirm it's taking them out, but I can confirm by my skin feels better, my hair is less dry, so I got a shower head filter for like $150 for my shower. So there are things you can do. I mean, they make air purifiers, and ultimately, especially, and I try so hard not to judge, but it's challenging when you've got children who might living right next to these facilities, who are obviously the whole family's having health impacts. And I understand why a lot of people can't move. I get it. You can't sell your house, but I also, it's just, I don't know where I'm going with this, but I don't judge, but I do wish they had the option. The industry could just buy them out, relocate people, especially near compressor stations, because they're a continuous and constant source of air pollution. And have you studied that, or you've known that as well? Like the compressor stations are particularly bad for air pollution. And I got that information from environmental attorneys I've been working with for years. They say a lot of their clients are folks who are sick living near compressor stations. So,
yeah, that's not something I actually have had the opportunity to look at in my research, and there isn't that much that I'm aware of the compressor stations. I wanted to circle back one more to your point too about kind of the sustainability of doing this type of research. And I just wanted to add that in my work, I have some studies where I look at all this existing data. I'm sitting at my computer, I'm doing statistics and writing, and then other parts of my research involve going to the field and talking to the participants and things like that. And I think, first of all, both are beneficial, because first, as I mentioned before, you can't do like a cancer study. Well, it would be very resource intensive and not that feasible to like study thousands, 100,000 births, going door to door. So some of it is when you just use existing data, you can look at a lot more people. And when you're going to homes and doing more detailed studies, just by the nature of it, you can only do a smaller sample. But I just wanted to say that talking to you, Jill and Stuart, talking to the participants, that really helps with the motivation. That's all the motivation you need when you hear that you're providing people with information that they're grateful that you're there and you're studying this issue that they're dealing with. That's a huge motivator. And every time I talk to you, Jill, it motivates me more. So that certainly helps with the sustainability of the work.
How important do you think, like one of the things that Jill's really, since I've known her, community-led science has been a big part of what Jill's done. And it's actually how her and I met. How critical is that, do you think, in the big picture of understanding these industries?
And community science to me means I'm a community member and I do my best and pray and, as many scientists, researchers as I can to support, help, but also like some retired scientists who live in the community now offer their support. So that's what community science means to me, is like having the community engaged with the researchers to help support and produce the data.
Yeah, I mean, I think there's been a lot of increasing recognition of just the value of working with communities. There's, different ways to involve the community. And I think, the best, when it works best, the community is involved kind of before, the beginning, the middle, the end, all of it. That's, certainly what I strive to do. It's hard. It takes time, right, to build these relationships and trust and all of that. But yeah, I mean, just being out in the community gave me the idea to do the cracker plant study. Talking with Jill gave me ideas for how to better design my drinking water study. Just going around doing a tour with Jill, I saw these work camps of, rows and rows of camper vehicles of these workers, non-local workers who would come into the state to do work on the pipelines and things like that. And that gave me the idea. I thought, well, anytime you have an influx of all these male workers, that can bring with it sexually transmitted infections and other social issues. So I did a study on that. So I just think it's incredibly valuable for trust, for participation, to inform the science. And there's just so many benefits to having these types of relationships.
But I have to take it back a step. I agree with everything you just said, but the man camps, as we call them, and the STDs, and I would add to that, like talking to the local police and other sheriffs and the drug use, but your study confirmed there an increase in STDs in areas where the man camps were located, right? Or
we
an
did see an
association.
Yeah. I was surprised. I wasn't that surprised that we were able to detect it, as we tried to control for other factors again. But we certainly saw the association. Mm-hmm. Mm-hmm. Yeah. And here's another thing we did too. We looked at other infections. I think we looked at like salmonellosis, right? So if for some reason this association with STDs was like because due to some changes in how like infectious diseases were being reported or recorded or anything like that. So we looked at something we would not expect salmonella cases to go up because we had workers in the community, and so we call that a negative control. And so we did not see a correlation with salmonella. We saw it with the STDs. That just was because Stuart, you asked kind of how we try to, isolate a certain exposure. And that's just one example of one of the things we can do with our statistics to see, this thing that we didn't expect to see. We didn't see that. That wouldn't have made sense. But we did see the association with STDs.
Did you know that?
No, I didn't. But it makes sense though.
Yeah.
Because I mean, I have friends from high school and college who ended up working in the oil and gas field, and they would tell me stories about what it was like in the field, and how they would get shipped out to a site in the Midwest, and then they'd end up in the Gulf South, and then they'd end up in Appalachia, and there were lots of stories about risky behavior. So it does make sense. I'm curious if you could speak to this issue that I have noticed where, there seems to be a disconnect between like the general public, and particularly in events like the East Palestine train derailment, where you have sort of a community that is experiencing this lived reality that is outside the norm of what they normally experience. And so they're associating it with the train derailment. But then you also have kind of the scientific community that in many cases is telling them that their air samples are showing that there's no concern, their water samples are showing there's no concern. And so there seems to be this disconnect sometimes between what science is telling us and what our lived experience is.
Right.
And I think that fosters a distrust of academia and government institutions, regulators. And I'm just wondering if you could maybe speak to that, if you have any thoughts on why that disconnect exists, how people should, approach that disconnect or better understand it.
Well, I'd love to hear your thoughts too, Stuart. I know from like a scientist perspective, when sometimes it's just challenging when people, perceive that they have been harmed or exposed, maybe even experiencing symptoms, and then scientists come in to try to, take some measurements to try to understand the issue. Part of it may be, not knowing necessarily what to sample for.
Right.
In the case, like if it's a specific case where the pollutant is known, then maybe measurements can be taken for that. Sometimes it's we're not sure what the kind of main agent is that we have to be concerned about. So there may be issues about like what to sample, where to sample, when to sample. Those can be challenging. So sometimes, again, the people may perceive there's a harm, and scientists may be coming in and doing the best measurements, but there may be, in the absence of sort of complete information, those could be some things that come up, just not the measurements not correlating with, the symptoms, and maybe it's because they're not measuring for the right things or.
Right, which was kind of, I actually just had a flashback of, I got asked by Dr. Yuri Gorby and Dr. John Stoltz from Duquesne, Judy Westrick from my mind. Anyway, I got asked by folks I'd worked with in the past, researchers, scientists I've worked with in the past, to help with East Palestine train derailment and the sampling we were going there. But I just remembered that I reached out to you in the middle. I mean, that was traumatic for me too, and simply because I have my mom who's calling me like, "What are you doing? Don't go up there. You're exposing yourself to stuff. Like, why are you doing this?" And like, but for whatever reason, they asked me to help, and I had to. It really wasn't a choice. And thinking back, I should have probably had better protective gear, but I did what I did. But I remember I reached out to you at one point, and maybe it was about dioxins, or I'm not sure. But, even in that time of crisis, like, Nicole, like, there you were, our connection. So whatever, I'm sure, I can't even remember the interaction, but I just want to say, just knowing you and having our connection helped so much during that tragedy,
Thanks, Jill. And this reminds me of, it almost doesn't matter if people are experiencing symptoms. do we even necessarily need to figure out which exposure to what is the problem? I mean, it's important to figure that out. But also, say with oil and gas, well, we're seeing increased birth defects, cancer cases, birth outcomes. Do we know if it's the air or the water? No, we don't know that yet. But is that important? Do we need to know that? Is it enough just to know there are these harms? It's related to proximity, or, we think it's related to this train derailment. Sometimes we don't have to wait to have all the answers to take action. We should still try to get the answers, but it shouldn't be a reason to hold up public health interventions, which, it can be used as. I don't know. Stuart, does that sound satisfying to you?
Yeah,
I know
no,
it can be hard when there are things like cancer clusters. Some of these things are just like hard to prove mathematically.
Right. No, I what you just said is kind of the perfect response, because that's the response that I wish we got more of from the scientific community and regulators when something like the East Palestine train derailment does happen.
Right.
Because I think what frustrates the general public a lot is, and I mean, I'm just speaking for myself, but I think that this probably resonates with a lot of people, is it frustrates me sometimes that folks in certain positions of leadership just somehow seem allergic to saying, I don't know, but we should be concerned.
Or we don't have enough information, or just like you said, you're not testing, we don't know exactly what to test for. And like, I remember they weren't testing for dioxins
Right.
in East Palestine in the beginning, but then the researchers I was connected through from Beyond Petrochemical Calls and others was like, you really need to be testing for dioxins. So yeah.
The frustration from that disconnect that I mentioned earlier, a lot of it comes from the fact that it's like the people in charge, whoever they may be at any given time, just will not say what you just said, which is that we don't really know, but obviously common sense tells us that there's a problem here and that we should intervene because people are experiencing it. We don't need to wait 6 months to get this certain data to know that like people are suffering right now. And so I do appreciate you saying that from the context of being a researcher, just kind of acknowledging that like, yeah, we're not always going to know exactly to the T what's going on, but that doesn't mean that we should be dismissing what's right in front of us.
And is that what you said? Is that a good summary?
Yeah.
Just confirming. Is that true? I mean, the way he summarized that. Very well said.
Yeah. It's good food for thought for scientists. Obviously, we're in a time where there's a lot of mistrust of science. So I think it's just good. It's good feedback just to think about how we can communicate better in the face of nuance and uncertainty.
I guess the one question that came to mind for me is, how often, if ever, are you in conversation, communication with the regulators? Or is that like, you came here, you did your studies, there's an association with this or that, and then it's up to the community members, or who shares that with the regulators? The folks who are working on policy issues, or who gives it, I'm just curious, is there any method for that? Or how often are you in communication with regulators and policy issues?
Well, much like working with community, I think it is helpful. I mean, that they're another community stakeholder, I think, regulators, and it is helpful to talk to them about what type of question they need answered to inform their policy. So one thing is just when we publish our studies, they're available then to be used by different regulators. But some of the most meaningful work I did was serving on this public health advisory panel for the state of California, where we synthesized research on oil and gas to inform a new setback distance, and that's the allowable distance between oil and gas drilling and sensitive receptors like a home or a school or a hospital, things like that. And it was really helpful to see because, as scientists, we're trying to model the groundwater and the air and the wind and, all of these things I talked about, make these really, specific and accurate models, but they just want to know how close is too close. How close is safe? How far do we need to be? And that was just one example where I thought, oh, this is so helpful, because the studies weren't really designed to answer that specifically. So it informed me. So I'm like, okay, now in my next study, I'll do a highly specific model, because I do think it is important to try to disentangle these different exposures, but then also just do something simple and just do both side by side. You have them both available, and one's very interpretable for the community or policymakers, and the other one may give you a greater degree of accuracy or statistical power. So I think there's a lot of benefit to having those conversations. So they do happen. They probably could happen more, but it's very beneficial.
That's incredible news, by the way, about the setbacks, and thank you. Yay, Californians, they lead the way in a lot of things, so that's really encouraging. I want to keep talking, and I want to talk forever and for always, and I don't know, as often as we could get you here, there's so many, 30 of your own peer-reviewed papers, I want to dive into the depths of your research and what you found, particularly, and maybe in the next interview, I would love to know more about, boy, it almost makes me emotional trying to say it, how this is affecting our children, and yeah. And somehow, some way, I host weekly calls, and I'm always, my goal is, how did you say it earlier? The data, the science, the information is empowering and motivating. And so we try to stick with that, and I try to bring that in as much as possible, come back to the light, because so often these conversations can be heavy. So I can say my connection with you helped, 10 years ago. I wouldn't be sitting here. I wouldn't be with Stuart. So much would be different in my life if we wouldn't have had that original connection. And it kind of started our paths together, even though we haven't been in constant contact weekly, or, it's, there's been some gaps in between, but I love you. I respect you. I'm so grateful for your presence in my life. And this has been really good for me today on many levels. So I just want to say thank you. And Stuart, I've been wanting you to meet Nicole and to have this. We've been talking about, actually, it was one of the first things we decided over a year ago. Now I was we got to get Nicole Deziel on here. So, this has been a while in the works for us to be at a place where we felt like we were ready to bring you in,
Mm-hmm, mm-hmm.
Yep.
Yeah. And we have, our second interview with Nicole Deziel is on the calendar. That is coming, and we will dive into the details of your research, and I'm really looking forward to that. But this has been a great primer, I think, to set the stage for that. I don't think it would have been hard to talk about the research without kind of setting the stage first, I think. And so I'm really glad that we had this conversation, and it was really a pleasure, Nicole, to finally get to talk to you at length.
And I just want to make sure you don't have any questions for us. We've been hammered you, but how are you feeling?
I have lots of things I'm curious about from your perspective, but I'll just say, Jill, my heart is full also. Thank you so much for those really gracious words. And I just can never thank you enough for helping me also get my research off the ground. It was really your connections and your generosity was so instrumental in helping me get that first study So I deeply appreciate this. And I also found this rather uplifting, even though we were talking about something heavy. It's nice to be kind of in community and talking about the science. And I think that really highlights sort of the relationships or the humanity of science.
Yes.
I think that's really important as well. So I look forward to continuing the conversation. And thanks so much for this opportunity.
Thank you so much. So much appreciate you, and you too, Stuart and Grant. Thanks for your help. So until next time, guidance protection.
Thanks for listening to Exposure. To learn more, support our work, or find out how to get involved, visit ohiovalleyallies.org. Exposure is hosted by our founder and frontline advocate, Jill Hunkler. Our co-host and executive producer is Stuart Day. Director of Operations is Waya Slater. Video editing and audio-visual production assistant is Grant Newman. And our original theme music is composed by Spencer Day. If you've been impacted by oil, gas, or petrochemical industries, or have questions and feedback, we'd love to hear from you. Reach us at info@ohiovalleyallies.org. Thanks again for being here. We'll see you next time.